We continue Unit 17, Rewriting Logs and Exponentials, Evaluating Logs Without a Calculator. Since exponentials and logs are inverses of each other, you can write either type of expression in the other form. The definition of a logarithm states if b and n are positive numbers, b is not equal to 1, then log base b of n equals k, if and only if b to the k power is n. The exponent k in the exponential form is the answer in the logarithmic form. The base b in the exponential form is the base of the logarithm. Basically, this just says because they're inverses of each other, we can write a log to look like an exponential, and we can write an exponential to look like a log. We read this expression, log base b of n is k. I can rewrite this logarithmic expression to be an exponential because they're inverses of each other. Start with the b. The b is the same base in the exponential as it is in a log, so that's going to be my base. Raise it to the k power and set that equal to n. We can also do this the opposite way. We can start with the exponential equation and make it a logarithmic equation. Start with the base. The base of the log is the same as the base of the exponent. Log base b of n is equal to k. Write each equation in the other form. In this problem, I have the logarithmic function. I do not have the exponential, so I will rewrite it. The base of the log, 3, becomes the base of the exponential, raised to the 4th power, is equal to 81. Example 2. 4 raised to the 1st power is equal to 4. Now I have the exponential, but I do not have the logarithmic. So log base 8 of 64 is equal to 2. Next example. Log base 5 of 1 is equal to 0. In example 6, I have a fraction on this side of the equation, on the right side of the equation, but it doesn't change anything. 16 raised to the 3/4 power is equal to 8. These are all true statements. Turn the flap over, and we have directions to evaluate the following logarithms without using a calculator. This is really easy. We first rewrite the expression. 5 to some power equals 25. I'm going to put an X here because that's what we're used to, something that's unknown. What do we raise 5 to get the 25? And the answer is 2. If you don't remember, we just took a test and we had to rewrite to get the same base before we could solve. And I can rewrite this expression to be 5 squared. Once the bases are the same, we set the exponents equal to each other and solve. So x is equal to 2. Example 2. Log base 4 of 16. So what we have is 4 raised to some power is equal to 16. Well, 4 squared is equal to 16. If we didn't remember that, however, we can just rewrite to get the same base and set the exponents equal to each other. 4 to the x is equal to 4 squared, so x is equal to 2. 4 raised to some power equals negative 16. Let's think of this. 4 squared is equal to positive 16. 4 to the negative 2 is equal to 1 over 4 squared, which is 1 over 16. This is not possible. Cannot raise a positive number to a power and get a negative number. Example 4. 10 raised to some power equals 10 to the third. Remember, as long as the bases are the same, we can set the exponents equal to each other and solve. And our blank is 3. Example 5. 3 raised to some power equals 1/3. 3 raised to some number equals 1/3. Remember, to get the same base, I would need to bring 3 to the first power to the top. Now that the bases are the same, we set the exponents equal to each other and solve to get negative 1. To go from a whole number 3 to a fraction with 3 on the bottom, a negative exponent is required. Example 6. 9 to some power equals 3. If I change these to the same bases, then 3 squared is equal to 9. Remember, I multiply the exponents together. Is equal to 3 to the first power. Now I have like bases. 2x is equal to 1, so x is equal to 1/2. The square root of 9 is equal to 3. Therefore, 9 to the 1/2 power is also equal to 3. To make a number smaller, you need to take a root. Therefore, a fractional exponent is required. Number 7. 16 to some power is equal to 1/2. Remember, I could set the bases to be the same, so this is the same thing as saying 2 to the 4th times x equals, this is a little 1, so I need to bring it to the top. So this is 2 to the negative 1 power. My bases are the same, so we set the exponents equal to each other and solve for x. So the blank here is negative 1/4. So to go from a whole number to a fraction, you need a negative. And this concludes day 2 of your foldable.